Going on to topic 3 now of chapter 7, multiplying radical expressions. And they're giving us a little thumbs up here in the beginning. Note that if you have the square root of 4, which is 2, and the square root of 25, which is 5, 2 times 5 is 10. Now if you also multiply the radicands, 4 times 25 is 100. The square root of 100 is also 10. So in theory, what we can do is keep in mind that we can, as long as the index numbers are the same, we can multiply our radicands, and that will still be an answer for what we're getting. So there is the rule, and we're going to continue. So again, as you read your textbook, you look things over, you go back, you can take notes on it. Any of those things would be satisfactory and useful. So let's do this then. So this is going to be, we say we can just multiply these, the square root of 15. Now since our index numbers are the same, this is going to be the cube root of 20. And we're going to multiply this. Now notice what happens here when we do this multiplication. We get the square root of, these are conjugates, so we're going to get x squared minus 9. And here the index numbers are the same. So we just put it in fraction form, 7y over 5x. Okay, now of course your text will illustrate this and show you all kinds of things here. And they're reviewing these conjugates here. Now, are they asking us for domain here a little bit or whatever? Well, we're not going to go there right now. Now, they are asking us to start simplifying radical expressions by factoring. Okay? So keeping in mind, if we have this, we could separate it into different radical factors. And again, they must both be real numbers, and the index numbers must be the same. So let's take a look at this and start to develop strategy. So if this is the square root of 20, and they're asking us to simplify that, well, we know that this could have been the square root of something times the square root of something. Now, suppose as we look at this 20, and what we want to try to look for is a perfect square factor of 20. Now, we can go 1 times 20. We can go 2 times 10. We can go 4 times 5. And then the largest perfect square factor that we can get out of 20 would be 4 times 5. So under this radical sign, we have put a perfect square. So this then will become 2 the square root of 5. We have simplified this, and that's what they're showing you here. And I gave you my little interpretation. So these are the rules, and we'll be practicing them. So let me set a few of these up here, and we'll start off with 2. Now what we want to do here is to break that down into 2 sets of radical factors. They have the same index number. Now we're looking for factors of 200, one that would be a perfect square, the largest perfect square. Well, that's 100 times 2. So now we take the square root of 100 and get 10, the square root of 2. And now in this next one, again, we're hoping you're developing a technique. 2 sets of radical signs, because we want to factor this into any perfect square factors under the first radical sign. So can you all see 9 times 2, where 9 is a perfect square? R squared, or any multiple of 2, is a perfect square. And this part is not, so that goes here. So our strategy is to divide the radicand into a perfect square factor, and then whatever's left over. So this will become 3r, the square root of 2y. And we'll go on. Now your textbook is doing it a little different way, but again, there are different ways to do things. So as we look at example C, again, we've set it up with 2 sets of factors with the same index number. Now we're looking for factors of 72 that might be a perfect cube. Now let me go over a strategy to figure that out. So we have 72. Suppose you didn't know how to do it. Well, you would divide 2 into there, and that goes 36. You go 2 into there, and that is 18. Divide 2 into there, and you get 9. And that's 3 times 3. Now, can you see you have 2 times 2 times 2, which is 8. 8 times 9. Now, you may have known that already, and remember this has to be a negative. So the cube root of a negative 8 is a negative 2, the cube root of 9. And this would just be a way to figure it out if you didn't know these. And again, if you divide this by 2, you get 81, which is a perfect 4th power. Again, if you didn't know that, you might have to do this technique. And then what would be the perfect 4th power of x to the 6th? Well, x to the 4th. And remember, you had a 2 left over, and you had an x to the 2nd left over. So now the 4th root of 81 is 3. The 4th root of x to the 4th is x. And the 4th root of 2x squared. And of course they have it all written out down here. They're doing it a little different way than I'm doing it, but either way is good. Study it, develop a technique. You want to be able to get the right answer. And here they're just giving you some more technique. Now for this one, a couple of things are going on. So let's look at this. They want us to simplify. And we can just use what they have in the book too. Well, sitting at my desk, we get phone calls from time to time, yes. Okay, so as we look at this, what can we start to do? Well, can you see we can factor out a 3, which is what we've done. And then when we factor out the 3, notice we can then, this is a perfect square trinomial that can factor into that. And then we can take the square root of that, divide it into 2 parts, and then this is what we get. Now, again, I'm not going to be critical about putting in the absolute signs here, although that is a good practice. Let's continue. And they give us letter A, and let me work that for you. So for letter A, again, we want to put under one radical sign as we factor this, those that are perfect squares. And then anything else that's left over, we put over here. So for x to the 7th, x to the 6th, anything even would be a perfect square. And one left over. Y to the 10th, and then anything left over. And then z to the 8th, anything even would be a perfect square, and then 1z. So then this becomes, just dividing all of these by 2, x to the 3rd, y to the 5th, z to the 4th, and then the square root of x, y, z. And I guess they're doing all of that there. And a little different technique, but that's good. All right, let's go to the next one. In this next one now, again, we're trying to factor this radicand into 2 factors, one that will contain perfect cubes. Well, 8 is a perfect cube. What's left over is the 2. Now here they're going to be multiples of 3. So a to the 6th, and there's an a left over here, and this will be b to the 12th, and there'll be a b squared left over. So now we take the cube root of this, which is 2, dividing everything by 3, a squared b to the 4th, and then the cube root of 2ab squared, and I believe that's what they have too. Okay, again, theirs is a lot more steps. I like a way, and that's what I'm doing. Okay, let's continue. Now, what they're going to ask us to do is to multiply and simplify. So let's take a look at some of these. Now, there is a strategy, and I'll show it to you. So as we look at the first one, we have the square root of 15 times the square root of 6, which is the square root of 90. And the square root of 90 is the square root of 9 times the square root of 10. That's using the technique we had before. And the square root of 9 is 3, the square root of 9. Or I should say 10. What am I doing here? I said 10. I wrote 9. All right. Glad I caught that. Yes. Now, notice what's going on here. This is actually the square root of 3 times the square root of 5. This is actually the square root of 3 times the square root of 2. Can you see here, if we multiplied these two, we would have gotten the square root of 9, and multiply these two, we would have got the square root of 10. So that is just some background of what's going on. We could do it this way, or we could do it this way. Now let's look at the second one. So in looking at B, you see we have a 3 times 2, which we can put over here just for a moment, and then put this under a common radical sign. So this is going to become a 6. This becomes the cube root of 5 times 5 times 5, or the cube root of 125, which is a perfect cube. Another way to look at this is 5 to the third here. So this will be 6 times 5, which is the cube root of 125, which gives us a 30 right down there. And the last one. So I'm playing around with this a little bit here. And this, again, we want to put all of our perfect fourths under one radical sign as we factor this, and all what's left on the other. So I need 4 2's, 1, 2, 3, 4. Put them under this, that will be a 16. I'm going to use x to the third, x to the, and then there's, let me see, I have 1, 2 left over here. X to the third, x to the second, so I can take out x to the fourth, and I have 1x left over, because that's x to the fifth. Take out 4, and then here I'm going to have y to the eighth, which is a perfect fourth, and that's what I have. So now I take the fourth root of 16, which is 2, divide this by 4, that's x, divide this by 4, that's y to the second, and the fourth root of 2x. Wow. Okay. And again, there are different techniques. I've just tried to illustrate here a little bit. This technique that they're using actually is pretty good, except I would have done it this way. But, again, good stuff. And that will complete this. Wow, just under 18 minutes.